Hello, everyone. In this video, we're going to get started on section 17.1 on parameterized curves. So in general, a parameterized curve is a curve, meaning an image or graph I can draw with my pencil, that's parametrized, meaning that there's a certain way to transverse or move along the curve. All right, we're going to get started right away on this preliminary example. We're going to start making more sense of what these parameterized curves can look like and how they're defined. So first, let's go ahead and sketch the space curve, so a curve in space, given by the function r of t equals x of ti plus y of tj, for t going between 0 and 2 pi, where x of t is a function given to us by -1 plus 3 cosine t, and y of t is a function given to us by 1 plus 3 sine of t. All right, so let's go ahead and fill in this table, and then we'll draw our curve to help make sense of what this object is. All right, so let's just get started with t equals 0. So when t equals 0, let's compute x of 0 and y of 0. So x of 0 is going to be, following the rule given to us by what the function x of t is going to be -1 plus 3 cosine 0. So now cosine of 0 is just 1. So that's going to be -1 plus 3 times 1, which will be equal to 2. So we can fill in here, x of t for t of 0 is 2. So now we can do this with y of 0. So I'm going to follow the rule for y. So y is 1 plus 3 sine of 0. So that's going to be 1 plus sine of 0 is just 0. So 1 plus 3 times 0, which is just 1. So I can fill in 1 into my y of t. So that means the output, the vector r of t, looks like 2i, 2 in the I direction, plus j. All right, so we could draw this on our graph to the right. We can follow 2i, 1j. So our point would be here. So this is r of 0. So I could draw in the vector. That's totally okay because we do have a vector here. I'm just going to leave it off for the moment because it's going to kind of clutter up our picture a little bit. So let's draw this dot here to signify the end or the arrow of the vector. All right, so let's go ahead and do this for a few more t's. So let's try t equals pi over 2 together. So we're going to plug in pi over 2 for x and for y, or into our x and y functions. So x of pi over 2 is -1 plus 3 cosine of pi over 2. So recall cosine of pi over 2 is 0. So this just becomes -1 plus 0, which is -1. And then following the y map, we have 1 plus 3 sine of pi over 2. Sine of pi over 2 is 1, so this becomes 1 plus 3, which is 4. So we can fill those in. So the x is -1, and the y is 4. So the vector r of t would look like -I plus 4j. So we can go ahead and fill that in. So we have -1 in the I direction plus 4j. So this point would be the arrowhead of the point r of pi over 2. So what I'd like you to do is pause the video and fill in the rest of the table on your own. And then go ahead and continue the video to compare your answers. All right, so as we continue this table, we should be getting -4 and 1. So that would look like -4i plus j, then -1, -2, which will be -I minus 2j, and 2i, which will be, or 2, 1, which will be 2i plus j. Awesome. All right, so let's go ahead and plot those points. So we see that r of pi will be at -4, 1, 2, 3, 4, +1 right here. So this will be r of pi. Then we have -1, -2 for r of 3 pi over 2. And then we have 2, 1, which is the same point as r of 0, r of 2 pi. Awesome. Okay, so it's kind of hard at this point to tell what kind of curve is being drawn out here by the function r of t. Keep in mind here, we just plotted 4 or 5 distinct points, not the entire curve, but we could have tested all the points in between 0 and pi over 2 to determine what this curve actually looked like. So it could be, it's kind of looking like it's going to be maybe a circle. Where does that center look like the circle is? Maybe around -1, 1? So how could we check this? So can we check that the curve r of t is a circle at -1, 1? Yeah, well, we can check that what this curve is and check in particular if it's a circle with this center at -1, 1 by plugging in the maps for x of t and y of t into an equation of a circle centered at -1, 1. And in fact, we can look a little bit deeper and see that it looks like the radius here is going to be 3. So circle centered at -1, 1 with radius 3. All right, so let's go ahead and do that together. So I'm going to erase here to give ourselves more room. Feel free to leave your work though, so that you can keep track of where we are going. All right, so the equation of a circle centered at -1, 1 with radius equal to 3 is, let's recall, it would be x plus 1 squared plus y minus 1 squared equals 3. In general, that equation, if our center of our circle is hk, the equation of a circle with radius r looks like x minus h squared plus y minus k squared equals r squared. So that's why you see the plus with the x here if our center is at -1 in the x direction, and then a -1 next to the y if our center is at the +1 in the y direction. All right, so that would be the equation of a circle with those parameters. So what we can do is check to see if our maps x of t and y of t satisfy this equation. All right, so let's do that. So that means we need to just plug in those two maps. So I'm going to write then x of t, which is -1 plus 3 cosine of t plus 1 squared plus y minus 1. So we have 1 plus 3 sine of t minus 1 squared. I want to check, does that equal 9 or 3 squared? So let's go ahead and work out that left-hand side. So we see that the 1 and the -1 cancel, and the 1 and the -1 cancel for both terms. So this would imply 3 cosine t squared equals 3 sine t squared. Well, that becomes 9 cosine squared t plus 9 sine squared t. So from there, I can pull out a 9 from both sides, or both terms. So this is just equal to 9 times cosine squared t plus sine squared t. And we can recognize that cosine squared plus sine squared is always equal to 1. So indeed, we have that our original left-hand side, our x function plus 1 squared plus our y function minus 1 squared is always equal to 9. I missed a square here, so it doesn't look quite accurate yet. we see here that we do need the radius squared on that right-hand side. So check. So to summarize, this shows that R of t is the curve that determines or draws out a circle centered at -1, 1 with radius equal to 3. Awesome. And if we think through how this curve, this circle is parametrized, we can see that as t begins at 0, we're going to begin here at this point here. Then as t increases to pi over 2, we're going to come in this direction. Then as we increase to pi, we'll come down here. As we increase to 3 pi over 2, we'll be here. And as we go up to 2 pi, we'll come back to our beginning. So R of t traces out this curve like this. Awesome. All right. Thanks for watching.